I'd like to start on the second page, everybody, which is page 2, lesson 4. Don't put the lesson booklet in your binder just yet, because you're going to have to flip through the pages, and I don't want you to rip the booklet apart, so keep it out on your desk. Starting with example 1, I'd like you to read it quietly to yourself and get a feel for what they're asking and what the gist of the problem is. So do that now, and then we'll come back. All right, so here's my first question. What is the given ratio? What ratio did they give to you in the first sentence? Ella, come near. Feel that frog. That is like the smoothest frog ever. No, seriously, put it up against your cheek. Put it up against. Isn't that the best? Isn't it great? Okay, I'm going to underline 2 out of every 5, and I'll put 2 to 5 above that. That's a key VIP. That's important. Okay, let me have that frog back. Make good throws because I'm wired up for sound here. All right, next question. Listen carefully. What do we know for sure about this class? Ready, Charles? Put that up against your face. Tell me it's not the softest thing you've ever experienced, ever. What do we know for sure? He just wanted the frog. He didn't even want to know what the question was. He just needed to have the frog. But he's going to do it right now. What do we know for sure about this class? You got it. Underline that. That's a key VIP. What's the number that's in question? Charles, you're going to have to surrender the frog because other worthwhile people want to experience the softness of the frog.
How many kids have you?
Right. What we're not sure of is how many have overdue library books. And that number 10 is being called into question. Circle that and put a little question mark above it. It's a key VIP, but it's the one that we're not sure of. So now we're going to prove or disprove it using equivalent ratios. It was close, wasn't it? We know 2 to 5 is definitely true. I should do that in green. Keep consistent with my colors. We also know that 25 is true. The number she's questioning is whether 10 kids have overdue books. Well, here's how we're going to do it. I'm going to scroll down. You're going to go to the bottom of your page. We know that the 5 and the 25 are accurate numbers. To get from 5 to 25, what are you multiplying by? We're going to put that in the box. That is called our constant. Everybody say constant. Now we'll go on to the next page. And if 10 is an accurate number, then what we should be also able to do is take the first part of the ratio, the 2 and the 10, and is 2 times 5 10? Therefore, this is the right number. It is an equivalent ratio, so she is right. Write the word yes for is she correct? She is. A constant is a positive number that both sides of a given ratio must be multiplied by in order to equal their corresponding quantities in the equivalent ratio. It's a little wordy, but what it means is that if the constant is true, this number that you're multiplying one side of the ratio with should also work for the second side, and it does. So in this example, what was our constant? Just say it out loud. What was our constant? Just say it. Just say it out loud. 5. That's going to go here. Let's go on to example 2. Same thing. Read it quietly to yourself. Get the gist. Okay, let's pick up where we left off. What is the ratio that they give you? Liam. Wait, Liam, here. You got to experience the frog. Right up against your face. The best. All right, what's our given ratio, bud? TVIP. And I'm going to put that ratio on our first line in colon form. Okay, ready? What's the number we're sure of? John. 18. Good, yes. That's the first part of our second ratio. What's the number that's in question? Ready, Grace?
30.
What's the number?
30.
Correct. This is the number we're not sure of. All right, here we go. Let's test it. To figure out what the value of C is, which is the constant, even though there's not a whole lot of room here, to get from 2 to 18, what are you multiplying by? Gabs. Correct. As of right now, that's our value of C. That's our constant. If this is an equivalent ratio, and if 30 is accurate, you should be able to take the second part of the ratio and multiply it by 9. And you'll see we have an issue, don't we? Will 9 work? It does not. Therefore, 30 is not correct. What should it be?
10.
We don't want to change this part of the ratio. We need to change this part of the ratio.
27.
Right. He would need then 27 quarts of water. Quarts or cups? Quarts. Okay? So therefore, he is not correct. He being Peter, he would need 27. Another example of a tape diagram. Okay, same thing. Read over the problem and get the gist of it. And then I'll come back here with you. What's my given ratio? Lydia. I'm going to underline that. What else do we also know for sure? Angelina. I'm going to underline that too. Two very important pieces. What's my tape diagram going to look like? How many boxes by how many boxes? I haven't been tossing this around. Well, right. Our given ratio is always our tape diagram. There's my 5 by 6. And also just be careful you count correctly, because a lot of times you know it, but you leave a box out because you don't count quite as carefully as you need to. That's my 5 to 6. I like to also put 5 and 6 before it, just so you could see that it's coming from here. All right, well, I'll take that. Now what do? Got to try to figure out my magic number. My magic number is my constant. How do I figure out what number needs to go in each box? Antonio, you got it. What do I do?
It is soft.
Yeah, it is. I wouldn't lie about softness of a frog.
You have to go to the cashews, and since you know the 6 boxes are total of 54, so
Okay.
you have to divide 54 into 6.
Okay, very good. My 54 represents my total number of cashews being modeled by my 6 boxes of cashews. Therefore, what is the magic number? I need a number that goes in there where it's a number times, in this case, 6 would make 54. Oh, Jesus. Trist. 9 is correct. That's my magic number, also known as my constant. 54 is my total cashews. I have to figure out the value of each box, which is your 9 times 6 making 54. Once you find the magic number for the box, it's good for every box. So don't forget to put 9 in each box for the walnuts. How do I now figure out what my total number of walnuts is? Kristen. And what do you get? You can either add 9 plus 9 plus 9 plus 9 plus 9 plus 9, or 9 times 5, and that gets you 45. And that goes at the bottom of your sheet. Think about what you just did. You've created an equivalent ratio. We had an original ratio of 5 to 6. Watch. You figured out that the constant is 9. So, times 9 gets you 45. 6 times 9 gets you 54. So 5 to 6 is equivalent to 45 to 54 with a constant of 9. We good? Very similar to what we did in lesson 3, just a different way that we are showing it, or a different way that you might see it in a word problem. Okay, so here's what's going to happen. You guys will work on this page on your own. When it's done, ready? When it's done, bring it to me. If you get the thumbs up, you are good to go on to exit ticket 4, which is due by the end of the period. Please do not forget your headings. Make it priority. Top of the page, get it done. Okay? All right, so work on this. When you're done, bring it up to me.